All right, now for the second lecture on interference of waves. We talked about how you have constructive, destructive interference depending on the phase difference, and you can cause that phase difference a number of ways. Well, the first one we want to talk about is path difference. So I think there's a problem in the book like this, but imagine you have two speakers, and they're separated by distance, and they're both emitting the same wave, the same frequency, and everything, and they're in sync. So when this one's emitting a high point and this one's emitting a high point, and then you come out in front of the speakers and you're going to walk perpendicular to the line that bisects them. What you will find is that you will get places where the sound's high, loud, places where it's dim. If you think about it, there's a path difference between the distance the two waves travel. We call it one of them R1, one of them R2. Delta R is that path difference. We don't care about plus and minus. If the path difference, as we saw in the simulations earlier, if the path difference causes them to line up peak to peak, that's going to cause constructive interference. And that'll be if the difference is either zero or a whole wave length. And so we do delta R over lambda is the same as the phase difference over 2 pi, or the phase difference is lambda times our phase difference over 2 pi. And so we get constructive interference. Remember we said happened when your phase difference was 0, 2 pi, 4 pi, etc. You plug that in, and it's just like we said. If they're a whole wavelength, two whole wavelengths, then the difference in their path, then they're going to still arrive where their ups are going up and down at the same time. On the other hand, if they're half a wave, so one's going up while the other one's going down, then they'll have destructive interference. Plug in what we found earlier for the phase differences of these odd numbers of pi, and you'll get odd number. You'll get, well, that's to keep us an even number, right? 2n plus 1, odd number. 2n plus 1 is going to be odd. Plug in 0, you get half a wavelength. You plug in 2, plug in 1, you get 3 halves, 5 halves. And so constructive interference, destructive interference. Whole wavelengths, constructive. Odd numbers of half wavelengths, destructive. And again, you can think about the simulations that we ran earlier. Okay, let's go back over to here and pull out one of those simulations again. So again, when they're arriving they're arriving together, 0 wavelengths, and we go over here and we go over here. Well, we can't quite go over a whole one, can we? We can only go where they're driving and canceling, but we can do 0. That's when that's constructive, and that's when that's destructive. And so that's the difference can be caused by a path length, and when we do, that's our conditions. All right, I'll see you in the next video.